So the first example says, determine which lines, if any, must be parallel. And it does have the word explain. So stressing that, if that's in the directions, we want to make sure we explain. And since we're determining which lines must be parallel, your explanation could be a theorem or postulate.
Okay.
All right, since we're not, the question isn't, are the lines parallel? It's which ones are, okay?
Gotcha.
Now, it does say if any, so could that mean there could be none?
Could be none.
Yeah, so just keep that in mind. Now, in the picture, I see 5 different lines. Now, obviously, some are not going to be, are not going to be parallel, like line R and line T obviously are intersecting. That's kind of a no-brainer. So we're going to kind of pick pairs of lines 2 at a time and focus on like a transversal just to see if that would help us. All right.
Okay.
So tell me which 2 lines you want to look at first.
Well, I want to look at P and Q because I noticed they have an angle on them and they're corresponding angles that are marked congruent.
Okay, so that means you're looking at P and Q and which transversal?
And the transversal's T.
Yeah, because if you look at S, so again, if you need to cover up, use your pencil finger. If I look at S and cover up T and I'm not looking at R at all, notice that there's no angle labeled up here. Could I just go ahead and say, well, this has got to be 80 degrees?
No.
Can I just
that
say
would
that?
knowing that it's parallel, but not.
Okay, so we can't use that idea of parallel in the picture,
Right.
right? So I'm covering up line R for right now, just focusing on P and Q, and I'm only looking at line T. And Ms. Hogramy said it perfectly. She notices the corresponding angles, and since those are congruent,
That means the lines are parallel.
so I could say line P is parallel to Q. Now,
My reason would be the corresponding angles postulate converse because I'm proving the line's parallel. So I know I want to use one of those
Okay.
converse theorems.
okay, so where do you want to go next?
Okay. I also see the 80 and the 100. So let's cover up line T
Cover up line T.
because those are both along line S. And that would be, and I can cover up line P because I'm really just looking at Q and R. And looking at Q and R, the 80 and the 100, those are consecutive interior angles. And those should be supplementary if the lines were parallel. And if I look at those are supplementary. They do add to equal 180. So because they're supplementary, I know that line Q and R are parallel.
And what's your reason?
That would be CIAT, converse, consecutive interior angle theorem, converse.
It's the converse again.
Again, yeah, because I'm proving the line's parallel. So I don't know that part yet.
Okay. Any
Okay.
other two lines?
Well,
like
I'm looking at
you
like
did
S and T.
P and Q and then Q. Okay, S and T. So which transversal?
Well, but here's the thing. I don't know any actual angle measures on T.
Yeah.
So I really can't do that.
like if you let's say we cover up these.
Yeah.
Just to kind of get a visual what she's talking about. If I cover up those S and T, there's no angles down here.
Right, and even if I
And-
left Q, because Q's got the most information, I don't know what that angle that's marked congruent. I don't know what its measure is. So
Yeah.
I can't really talk about
And
S
same
and T.
here. If I move the, and
Yeah.
there's nothing here. So S and T don't really help us out.
Right.
Okay, now that doesn't mean they're not parallel. We just can't
I
conclude.
can't prove it.
Yeah, we just don't have enough information about that.
Okay, so we've talked about Q and R, and we've talked about Q and P. Oh, I see one more thing.
What do you see?
I see that P and R are parallel to the same line.
So if I said, I could go ahead and say that they're parallel to each other then?
Yeah, and that's not transitive. We talked about that means that they're just parallel to the same line. So they're
So-
parallel to each other.
Parallel to the same line. That's why they're parallel to each other.
Exactly.
That's the one we learned earlier today. So don't forget about that. And if it helps, guys, if you want to label the picture, P and Q ended up being parallel, Q and R ended up, well, immediately those are parallel to each other.
Right.
All right? So just kind of keep that in the back of your mind. And again, notice our explanation. I mean, guys, it's
a theorem.
it's not lengthy at all. So just make sure you support it so we know what's your thoughts, what's your ideas. And again, it says if any, so there could be no parallel lines. In this case, we had 3 sets. So lots going on.
Okay. Oh, here we go. This one says determine which lines, again, if any, must be parallel and explain. So same idea as the last question. we've got a little different picture here.
Yeah. And the kind of going off of what Miss Hochgraby had me do on the last slide was she kind of took 2 lines at a time, focused on one transversal. I even covered up some lines for her, saying, let's get rid of that. The other thing, she looked for special angle pairs. Mm-hmm. So that's something to keep in mind. But the other thing to notice, and I'm hoping you all see it, is notice in the picture how it's labeled, there's things that are perpendicular.
Okay, yeah.
So keep that in the back of your mind, because we learned something today about lines that are perpendicular that could lead into some parallel, right?
Okay. Mm-hmm.
Okay, so I'm going to start with lines A and B. Okay. I'm just going to see, could I prove something about those? So lines A and B, and I'm going to focus on one transversal, and I'm just going to go down in order. Line C.
So let's cover these up for a minute.
Okay, line C only has something labeled in one of the lines, so that doesn't help me.
Okay.
Line D would.
Yes.
There's some stuff there.
What can you state?
Okay, well,
Is it a special angle pair?
I'm thinking a couple, and I like that question, because she said, is it a special angle pair? So that, I do agree with that. That is a special angle pair. So you could state, because those are consecutive interior angles, and since they're both right angles, essentially, they're going to add up to 180. So I could say line A is parallel to B because of CIAT converse. And going again, what she said, because, yes, is it a special angle pair? That's a question you want to ask yourself all the time.
Now, is that the only way I could determine those?
And that's kind of where the way I was thinking, and she made me switch gears, and I thought that was good too. I noticed since line A and B are both perpendicular to line D, they're going to be parallel to each other. So perpendicular to the same line, that new theorem.
So really, you could use either one of those as a reason. Yeah. And guys, I just want to emphasize that is okay to use either one. Yes. You don't have to have both of them. Okay. What about line E?
E doesn't help at all. Yeah. And we already proved A and B are parallel, so. But notice line E doesn't have anything on it at all.
So it's probably not going to be helpful to us, right?
No.
Just
probably
something to emphasize.
Going to keep that in mind.
Okay.
All right. So let's look at line C and D now.
Okay.
So line C and D, and I have 2 different transversals that could work. I'm just going to go left to right.
Okay.
I'm going to look at A first, so let's get rid of the B. And I'm also, can we get rid of line E too? Because I just
and it's really not helpful.
It's not really help us at all. No. Again, we can't use the fact that we're thinking parallel to find other angles.
Right.
So we couldn't just make up some things on line E and think that they were parallel. So we can't label some right angles on that because we don't know if
E is just really not helpful at all. It's just an extra line.
Mm-hmm. Okay, so I'm noticing line A is probably going to help us here because I have some things labeled at each intersection of C and D. Now, the first question that Ms. Hochgraby asked before was, I think, really essential on this. She said, are these a special angle pair? And what would you guys say? No, right?
Right, they're not. Not a special angle pair, but we did learn something else.
Yes. So I see that both C and D are perpendicular to line A.
So we can state that C is
parallel to line D.
Because they are
perpendicular to the same line. Now, can I say, cap?
Cap, okay. I can't use cap.
Well, or cap converse because there's no corresponding angles that are labeled there.
Right, exactly. Now, could I have done maybe let's say a
linear pair
and then done some corresponding, using that cap converse? Yes, we could have. And that's fine. We don't need it because we know that they're perpendicular to the same line.
So if you use a reason as one of the converse theorems, you would have to have something first. So linear pair postulate or vertical angle theorem, and then use one of the converse theorems.
Right, because I could have technically done from this, intersection at D, I could have talked about a vertical angle and then consecutive interior angles also. Mm-hmm. And that's okay. Those are other things you can do. But if you know that perpendicular to the same line, you don't really need them.
What's the point?
Exactly.
And my philosophy on it is whatever way gets me there the quickest, that's the way I'm going to use it. So something to keep in mind. That's what we're going to encourage. All right, so this question's a little bit different. It says, explain how you would show G is parallel to H. So when it says show, that's in a sense to me like we're proving it is.
Okay.
If you want to think of it that way. We're not going to do a 2-column proof. And the word here says explain, so we're going to probably have to provide some support, theorems, postulates. Now, can I use the fact that they are going to be parallel to support?
No, because that's what I'm trying to prove.
Okay.
That's what I'm trying to show.
Okay, so when I'm looking here, what kind of things do you see?
Well, I see the two X's, because right now I know that H is perpendicular to the line that's drawn. So I know that that's 90 degrees. But looking at those two X's that we have marked there, if they're a linear pair, which I can assume that from the picture, that they're a linear pair.
What do we know about linear pairs?
We know that they're supplementary.
So they can add up to
be 180. And I could show that X plus X equals 180. And really, hopefully this is one where if they're congruent, the only way that I can have supplementary angles that are congruent is if they were both 90.
So that means this is 90 and this is 90.
Exactly.
Now, this is essentially...
That's our work. That's our showing.
Yeah. But when it says explain, what would be my explanation for knowing that these add up to 180?
I could say that they are supplementary congruent angles.
But what supports that, though? Like, what kind of angles do we have here?
Oh, they're a linear pair.
So linear pair postulate
Linear
that's
pair
kind of the big
supports
idea.
that. Okay.
The only reason why we know they're supplementary is because the linear pair postulate states that.
Exactly.
Their linear pair means they're supplementary, which then we can kind of use this idea of the fact that they end up being 90. Okay. So have I shown it yet?
Well, I haven't really stated it, but yes, G and H are parallel.
And why are they going to be parallel?
Because and I could use a few different reasons. I could say that really, if I know that both of those X's are 90, I know that they're perpendicular. So I could say perpendicular to the same line. I could use the fact that I've got some corresponding angles that are congruent, so cap converse. But yeah, using one of those reasons to really state that because I know that I have those pieces that are either perpendicular or congruent, however I want to look at it, I know that those lines have to be parallel.
Good. And notice again, the explanation's kind of more a theorem or postulate. The showing kind of if there is any work involved. And since there's an X, usually you try to have to find the value of X. That kind of gives you kind of a guideline there.
Okay, this next one says explain how you would show that G is parallel to H. So again, they're giving us our outcome, what we want to show. So we want to show that G and H are parallel. We don't necessarily have that right now. I want to be able to explain how I would show that.
So it's kind of, in a sense, you're proving it.
Yeah, same idea as the last one. What do you notice in this picture?
Well, I see more than one transversal.
I do too.
So maybe let's focus on one transversal. I think that's been helpful.
Yes.
So if I look at the top transversal, like just cover up the bottom one for a second. If I cover that one up, all I have labeled is that one intersection for line G as 5x. And since I don't have anything over on that other intersection, I can't really use that transversal. So let's cover that one up.
Okay.
That really isn't going to help us. And this one does because there's something labeled at each intersection.
Exactly.
And something that Ms. Hook-Raby said a while ago, which I think keeps coming back to me, is, are these a special angle pair? Because that's essentially what's going to help us prove parallel. Right. So I look at that and ask that question. Hopefully you're asking the same thing and you're thinking, no, they're not.
They're not.
So we need to come up with one. Now, the only way we can do that is we can't use the parallel lines, right?
Right. So we're thinking, you have to think about within one intersection right now.
So what kind of things can I think
of?
So
you could talk about either linear pairs that you see, so we could use linear pair postulate, or vertical angles. And usually vertical angles are easier ones to use if that does make a special angle pair.
Okay. So let's do a vertical angle with the 5x down
Okay,
there.
so if I'm going to mark this,
that's going to be 5x. And I think labeling the picture kind of helps us see what you're thinking, okay? Now I have a special angle pair with the 180 minus 5x, and I know the only way that those two lines can be parallel is if those add up to 180. So let me just add them up.
Yeah, and they've got x's, so you may be thinking to yourself, how does that going to work? But let's just write it.
So let's add 180 minus 5x and add 5x to it. Well, here's the deal. We're trying to see if they add up to, we're hoping they will. Well, the negative 5x and 5x are going to cancel out. So that means that is 180. So they do add up to 180.
So because we know that these are what?
Consecutive interior angles. And they end up being supplementary. The CIAT converse shows that those are going to be parallel.
Exactly. Notice that our work here, it's really just showing that basically those two pieces do cancel each other out. But showing that the sum of these two angles is 180.
Now, what if, because you mentioned earlier before, is that I could have used linear pair postulate. So instead of using vertical angle theorem with that 5x, can I do like maybe
Could I find this?
You could. Or I was thinking the 5x over in that corner right here, finding the angle right above it.
Okay.
And so or to the left, whichever
to the left,
way.
either way.
To me, that
it's funny, we're thinking different ones.
To me, that's above it, and then that one's to the left.
Okay. I'm with you now. I'm with you.
I can't really point at it. Sorry, guys. So the one right above that is
right here.
A linear pair. Yep, the question mark. I know, we're all over the place, guys. Sorry. That is a linear pair with that 5x. And I know that if I know one of the angles to find the other one, you just subtract it from 180. So that would be 180 minus 5x, right?
Exactly.
And then that corresponds with that other 180 minus 5x.
So then you would also see.
And they would be congruent. So it just kind of depends on, so in this one, do you really have to find the value of x? Like the last one?
You really don't. You just need to show that they're either congruent, depending on what angle pair you look at, or supplementary.
Cool.